A brownout, characterized by a temporary voltage drop, can stem from several potential causes within an electrical circuit. In this specific scenario, the reported dimming of interior lights coinciding with the operation of an electric lawnmower suggests a few key areas to investigate. Firstly, the branch wiring serving the affected circuit is a prime suspect. Over time, repeated flexing and stress from plugging and unplugging the mower's power cord can weaken the conductors, increasing resistance and leading to voltage drops under load. Secondly, the circuit breaker itself could be failing. While less common than wiring issues, breakers can degrade over time, causing them to trip prematurely or fail to provide adequate current. Thirdly, the GFCI outlet, if faulty, can introduce unexpected voltage fluctuations. To systematically troubleshoot this issue, a step-by-step approach is recommended. Firstly, try plugging the electric mower into a different outlet located on a separate circuit. This will help determine if the problem is isolated to the original circuit or related to the mower itself. If the dimming persists on a different circuit, the mower is likely the source of the problem, and it should be inspected or serviced. If the dimming only occurs in the original circuit, proceed to the next step. Secondly, identify the specific branch wiring or components causing the voltage drop. This can be done by systematically disconnecting loads in the circuit. Unplug all lights and appliances connected to the circuit, and then plug them back in one at a time. Observe the lights as each load is added. When the dimming occurs, the last load plugged in is likely connected to the affected wiring. Thirdly, inspect the wiring connections at the outlet where the mower is plugged in, as well as any other outlets or junction boxes on the same circuit. Look for loose connections, corrosion, or damaged insulation. These can all contribute to increased resistance and voltage drops. If any such issues are found, they should be addressed by a qualified electrician. Fourthly, test the GFCI outlet. Reset the GFCI by pressing the reset button. If the problem persists, the GFCI may be faulty and need replacement. GFCI outlets are designed to protect against ground faults, but they can sometimes malfunction and cause nuisance tripping or voltage drops. To further isolate the problem, several electrical measurements can be taken. Firstly, measure the voltage at the outlet where the mower is plugged in, both with the mower running and with no load. A significant voltage drop when the mower is running indicates a wiring or breaker issue. Secondly, measure the voltage at various points along the branch circuit, such as at other outlets or light fixtures. This can help pinpoint the location of the voltage drop. Thirdly, use an amp meter to measure the current draw of the mower while it is running. Compare this reading to the mower's rated current. An excessively high current draw could indicate a problem with the mower or an overloaded circuit. In addition to these troubleshooting steps, it is important to consider the age and condition of the electrical system. Older wiring may be more prone to degradation and failure. If the electrical system is outdated, it may be worth considering upgrading the wiring and breaker panel. Also, ensure that the circuit is not overloaded. Check the amp ratings of the circuit breaker and all appliances connected to the circuit to ensure that the total load does not exceed the breaker's rating. Refer to the National Electrical Code, specifically Article 210, for guidance on branch circuit requirements and load calculations. Several factors can contribute to voltage drops in electrical circuits. Firstly, wire size is a critical factor. Smaller wires have higher resistance, which can lead to voltage drops, especially over long distances. The National Electrical Code Table 310.15 provides guidance on the ampacity of different wire sizes. Secondly, the length of the circuit can also impact voltage drop. Longer circuits have higher resistance, which can cause voltage drops. Thirdly, the load in the circuit can affect voltage drop. Higher loads draw more current, which can lead to voltage drops. Fourthly, loose connections, corrosion, or damaged insulation can increase resistance and cause voltage drops. To minimize voltage drops, use appropriate wire sizes, minimize circuit lengths, avoid overloading circuits, and ensure that all connections are tight and secure. When working with electrical systems, always take safety precautions. Firstly, turn off the power to the circuit before working on any wiring or components. Secondly, use appropriate personal protective equipment, such as rubber gloves and safety glasses. Thirdly, if you are not comfortable working with electricity, hire a qualified electrician. Ignoring electrical problems can lead to more serious issues such as fires or electrical shocks. It is important to address any electrical problems promptly and safely. In summary, the reported dimming of lights during lawnmower operation points to potential issues with branch wiring, the circuit breaker, or the GFCI outlet. A systematic troubleshooting approach, including testing different outlets, identifying affected wiring, inspecting connections, and testing the GFCI, can help pinpoint the root cause. Electrical measurements, such as voltage and current readings, can provide further insights. Addressing these issues promptly and safely is crucial for maintaining a safe and reliable electrical system. If you are not comfortable performing these tasks yourself, consult a qualified electrician. Furthermore, ensure that all electrical work complies with the National Electrical Code and local electrical codes. Proper grounding is essential for electrical safety. Ensure that all outlets and appliances are properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shocks. The National Electrical Code Article 250 provides detailed requirements for grounding electrical systems. Surge protection is also important for protecting sensitive electronic equipment from voltage spikes. Surge protectors can help to absorb excess voltage and prevent damage to electronic devices. Consider installing surge protectors at the main electrical panel and at individual outlets. The NEC Article 280 provides requirements for surge protection devices. Regularly inspect electrical cords and plugs for damage. Replace any cords or plugs that are frayed, cracked, or otherwise damaged. Damaged cords and plugs can pose a fire hazard or electrical shock hazard. Avoid overloading electrical outlets. Plugging too many appliances into a single outlet can overload the circuit and cause a fire. Use power strips with built-in circuit breakers to protect against overloads. Be aware of the signs of electrical problems, such as flickering lights, tripping breakers, or burning smells. If you notice any of these signs, investigate the problem immediately. Ignoring electrical problems can lead to more serious issues. Proper maintenance and regular inspections are essential for maintaining a safe and reliable electrical system. Schedule regular electrical inspections by a qualified electrician to identify any potential problems before they become serious. Keep electrical panels and equipment clean and free of dust and debris. Dust and debris can accumulate and cause overheating. Ensure that electrical panels are properly labeled. Labeling helps to identify circuits and prevent confusion. Use the correct type of light bulbs for the fixtures. Using the wrong type of light bulb can cause overheating or damage to the fixture. Avoid running extension cords under rugs or carpets. Extension cords can overheat and cause a fire. Do not use electrical appliances near water. Water can conduct electricity and cause an electrical shock. If an appliance falls into water, do not touch it. Turn off the power at the breaker and then retrieve the appliance. Teach children about electrical safety. Supervise children when they are using electrical appliances. Keep electrical outlets covered when not in use. Use tamper-resistant outlets to prevent children from inserting objects into the outlets. If you are planning any electrical work, obtain the necessary permits. Permits ensure that the work is done safely and in accordance with local codes. Hire a qualified electrician to perform any electrical work that you are not comfortable doing yourself. Electrical work can be dangerous, and it is important to hire someone who is experienced and knowledgeable. By following these safety tips, you can help to prevent electrical accidents and ensure a safe and reliable electrical system. This includes ensuring that all electrical work complies with the NEC and local electrical codes, which ensures adherence to standardized safety practices. Article 310.16 provides ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius.